Hello students, how are you? I hope you are safe. I welcome all of you on this educational platform. In the last class, we discussed about the fundamental particles of atom like electron, proton and neutron, discoverer, weight, mass, charge, specific charge. We discussed about the cathode ray, anode ray. Now in this class, today we will discuss about the atomic model. We will discuss about the Bohr's model of atom, velocity of electron, radius of shell and energy of electron. This is very important model of atom. So let's continue Bohr's model of atom.
So students, this is our second class of the chapter structure of atom, and today we shall discuss about the different atomic models. What are these different atomic model, who gave them, and what are the specific properties of these models. So the first model which came in front of us is the Rutherford's nuclear model of atom. This model was given by the Russian scientist Ernst Rutherford, and it is also called as alpha scattering experiment, as you must be knowing about this model from the previous classes, that in this model he bombarded various alpha particles towards the very thin layer of gold atom, and he found that most of the alpha particles, they go straight without any deflection from this gold atom, which clearly means that atom is hollow, or you can say that most of the part of atom is hollow, and all the mass of proton and neutron, in terms of the proton and neutron, it is present in the center of nucleus, called as center of the atom, called as nucleus. Rutherford was the one who used the term nucleus with respect of atom, although few alpha particles deflected by some angle, and one out of the approximately 10,000 alpha particle, it comes back at the angle of 180 degree, which simply possible when it is strongly repelled by all protons, which means protons in the atoms are not scattered like the Thomson said. Actually they are present togetherly in the central part of atom, called as nucleus. So in the Rutherford's atomic model, whole the positive charge of the atom is concentrated in the extremely small region in the center known as the nucleus. And the electron, where are the electron? They revolve around the nucleus with a very high speed in well-defined circular path, and these circular paths are called as orbits. Remember students, there is a difference between orbits and orbitals. Always remember this. Right now I am talking about the orbits, not the orbitals, right? And the electrostatic force of attraction between the nucleus and the electron, it keeps them intact, and they that is the reason why they do not go anywhere. There are some drawbacks of the Rutherford model, and as it was not very refined model, so there are certain drawbacks with the Rutherford model. First of all, it does not explain the stability of atom in terms of the force. How this atom is stable, it is not at all explained by Rutherford. Structure in which all positive charge present in the center, and that too is extremely small. Why this structure is stable? Because positive charge will repel each other. So why this structure is stable is not explained by Rutherford. Another point is, Rutherford model of atom does not describe anything about the distribution of the electron. Where are the electron? And what about the energy of these electron? Was not at all explained in this model. This model was also unable to explain the line spectra given by every element. In this unit only, in this class only, I will tell you about the spectrum. So Rutherford model was unable to explain the spectrum also. The drawback of the Rutherford nuclear model of atom was overcome by the new atomic model called as the Bohr's atomic model. So now we will switch towards the Bohr atomic model, although we will not discuss the Bohr's atomic model directly. Now in order to understand the line spectrum, you should know about the radiant energy. What is the radiant energy? And this can be explained by the electromagnetic wave theory and Planck's quantum theory. So come, let us discuss some important terms and theories like the electromagnetic radiation, electromagnetic wave theory, Planck's quantum theory before we studying Bohr's atomic model. So students, before we start the Bohr's atomic model, now I'll tell you something about these models. First of all, this is electromagnetic wave. You see, these are the radiation in which the electric and magnetic fields are associated and they are perpendicular to each other. You see in this picture, electric field and magnetic field. It is clearly visible that they are perpendicular to each other with a 90 degree of angle. So these kind of waves in which both electric field is present and magnetic field is present and that too is perpendicular to each other is called as electromagnetic waves. They are called as EMW. Sunlight is also a kind of electromagnetic wave. So what are the different characters of wave? Now I'll tell you about the different characters of wave. There are a few characters of wave like wavelength, like the amplitude, velocity, frequency and wave number. Right? So now we will start discussing these characters of wave. The first character of wave which comes in front of you is the wavelength. Wavelength is represented by the Greek term lambda. Spelling is LAMBDA where B is silent. Lambda. So what is lambda? Lambda is the wavelength. In simple words, wavelength is nothing but it is distance traveled by wave in one cycle. Or you can also say it is distance between the two consecutive crests of a wave, or troughs you can also use. So if this you consider as a wave, you see from here to here, this is one cycle. Now how much distance wave traveled in this one cycle? This much distance. This is called as wavelength. So this is the wavelength, is the distance traveled by wave in one cycle. Another property is frequency. It is represented by the sign nu. And what is frequency? It is the number of waves that pass through a reference point in 1 second, or in the simple words you can say it is the number of oscillations or number of cycle completed by wave in 1 second. This is expressed in the unit cycle per second or per second or hertz. Unit of frequency is also hertz. It was on the name of the scientist Enrico Hertz. When a cycle get completed, when one crest and another trough, that is a wave passes through a reference point, one cycle is completed. So how many cycles a wave completing in 1 second is called as frequency. Now what about velocity? Velocity is the distance traveled by wave in 1 second. And the SI unit of velocity is meter per second. So what is the velocity? Velocity of any wave is calculated with the help of Cn nu and also with the lambda, means frequency and wavelength. So nu is proportional to 1 upon lambda, and as a constant we apply nu is equals to C by lambda. This is how we calculate the velocity, where C is the velocity of wave, nu is the frequency of wave, and lambda is the wavelength of wave. What is wave number? Students, wave number is represented by the figure nu bar, and it is the number of wavelength per unit length. Number of wavelength per unit length is called as wave number, and it is generally expressed in terms of the centimeter. Although it is not necessary, you can also express wave number in terms of the meter or any other unit of distance, right? And the SI unit is meter inverse, because it is 1 upon distance, it is meter inverse. And these are some formulas for the wave number which you can remember. Another point is electromagnetic spectrum. So before we study electromagnetic spectrum, I should like to ask you one question. Do you know what is a spectrum? A spectrum is nothing, just arrangement of photons, arrangement of waves in the particular manner, in the increasing or sometimes decreasing order of their wavelength. So electromagnetic spectrum is the bunch of electromagnetic waves which are not random, but they are arranged in the increasing order of their wavelength. So when you arrange them in the increasing order of wavelength, you see when you arrange the photon like in this manner, where their wavelength increases, of course when wavelength increases, their frequency decreases, and this order is called as electromagnetic spectrum. In this electromagnetic spectrum, first of all, here comes the cosmic rays, then gamma rays, then X-rays, then ultraviolet rays, and there is a small region here is called as visible rays. Our human eye are sensitive to the visible rays only. It is not like that X-ray is not light. Yes, X-ray is also light, gamma ray is also light, infrared ray or microwave or the radio wave, they all are the forms of light. But the problem is we cannot see them with the human eye. This is the form of light which we cannot see with the human eye. So this wave from 400 nanometer to approximately 750 nanometer, which is called as visible ray, is visible for the human eye. So here we use the term spectrum. Like I told you, what is a spectrum? A spectrum is the distribution of colors or the photons produced when white light is dispersed by a prism. What is dispersion, students? When you pass a white light from the prism, after passing from the prism, when this is arranged over the screen, then all the photons which are present in this white light, they arrange themselves in the particular manner of wavelength, which is called as spectrum. Like this one, when you pass a white light or the sunlight from the prism. For the sunlight we use the special kind of prism which is Nicholl prism. After passing this light from the prism, there is a dispersion of light. Some waves of light show more deviation and some show less deviation, and then they arrange themselves over the white screen at the different distances according to their wavelength. And this order, this orderly fashion which is arranged over the white screen, students, it is called as spectrum. This arrangement is itself called as spectrum. I hope you are getting it now. Now, what is the difference between emission spectrum and the absorption spectrum? There are two kinds of spectrum, two major categories of spectrum, emission and absorption. As the name suggests, in the emission spectrum, there is an emission of waves. Now you see, what is the emission spectrum? It is the spectrum of the radiation emitted by an excited substance. Excited means the substance which is in the higher energy state. And absorption spectrum, it is the spectrum of the transmitted light by the substance after the absorption of certain radiation. Means when any substance absorbs the radiation, it results into the absorption spectrum. And emission spectrum is found when there is a emission of some waves. Emission spectrum is represented by some bright lines. Some bright colored lines you will see in this spectrum. While in the absorption spectrum you will see some dark lines. Dark lines means absence of photon. Absence of photon represents absorption. Bright line means presence of photon. And presence means emission. So this is the emission spectrum. Now we shall discuss something about the Planck's quantum theory. What is Planck's quantum theory? It was given by the scientist Max Planck. He gave the concept of quantization of energy. What is quantization? In the simple words, I can explain you the quantization. See, when any physical quantity is found in the multiple of some integer value, that is called as quantization. Like if you talk about our country India, here the currency of exchange of money is rupee. Now the minimum currency which is possible now in India is 1 rupee. You cannot make any payment of 25 paisa because now 25 paisa is not exist anymore. So we can make any payment which is in the multiple of 1 rupee. But you cannot make a payment of 23 rupees 56 paisa because now 56 paisa do not exist. It is not in use anymore. So rupee is quantized. Similarly, he explained that energy is also quantized. He said the word about the quanta. Now each quantum of radiation is associated with a fixed amount of energy which depends upon the frequency of radiation. So the energy of photon depends upon the frequency of radiation. E is proportional to nu. And he used the formula E is equals to h nu or hc upon lambda. You can replace nu with the c by lambda. Alright. So the energy of the quantum is given by the formula E is equals to h nu or hc upon lambda or hc into nu bar, which is wave number, where h is the Planck constant with the value 6.6 into 10 to the power minus 34 joule into second. Nu is the frequency of radiation, c is the velocity of radiation, lambda is the wavelength of radiation, and of course nu bar is the wave number. A body can emit or absorb energy only in whole number of the multiple of quantum. That is why we say that energy is quantized. So the radiant energy can only be emitted or be absorbed as h, 2h nu or 3h nu or 4h nu in the multiple. So now we say that energy is quantized. Now here comes the Bohr model of atom. It was given by the scientist Niels Bohr. He gave a model of an atom to explain the line spectrum and the stability of the atom. And what are the key features of this atom, this model of Bohr? He said that electron revolves around the nucleus only in certain circular orbit. It is not like that electrons are revolving in any second path or third path or any path you assume. They are revolving around the nucleus in the certain path and they are called as orbit. And energy of electron in these path or circular orbits is always constant. So they are also called as stationary orbit. Now in these energy level, electron revolving in a particular energy shell is associated with a fixed amount of energy. Say suppose electron is revolving in the first shell. So in the first shell, energy of electron, whatever it is, will remain constant always. And till the moment electron remains in the first shell, its energy will also remain constant. The moment it will change its shell, its energy will also change. Whatever the energy in the second shell will remain constant. Whatever the energy in third shell will remain constant. In the second postulate of Niels Bohr, he said about the quantization of the angular momentum. He said that angular momentum of electron, what is angular momentum, students? J, which is equals to mass into velocity into the radius of rotation, MVR, angular momentum. He also said that angular momentum of electron is quantized, means it is multiple integer of h upon 2 pi. It is n times of the h upon 2 pi, where h is the Planck constant, m is the mass of electron, v is the velocity of electron, and of course r is the radius of circular orbit. So the value of n could be 1, 2, 3, 4 or 5 or anything, but it cannot be 2.5 or 3.6 or 4.9. It cannot be in fraction. It will always be a multiple number, whole number. Now he says the jumping of electron from one energy level to the another energy level is called as the transition. And the transition of electron is of two types. Number one is the excitation. Excitation is from lower energy level to the higher energy level. If electron goes from low energy to the high energy, it is called as excitation. This transition is excitation. And suppose if electron goes from high energy level to low energy level, then it is called as de-excitation of electron. During the excitation or de-excitation, whichever take place, there is always involvement of photon. See, when electron goes from low energy to high energy, it would be requiring energy. And if it is coming from high energy to low energy, it will release some energy. In both the cases, energy will be involved, whether it will be absorbed or it will be released. So, according to the Niels Bohr, whenever transition of electron take place, energy is always involved in terms of photons only. Means energy is absorbed in terms of photon and energy is released in terms of photon. Whenever electron will go from low to high, it will absorb photon, and whenever electron will come high to low, it will release photon. And that is the reason why difference of energy of both shells, that is delta E, which you can say is E2 minus E1, is equal to the energy of photon h nu, or you can also call it hc upon lambda. So finally we can say that delta E is equals to h nu or hc upon lambda. Students, what does it mean? It means difference in energy. Difference in energy is always equals to the h nu. Means energy will be absorbed in terms of photon and it will be released in terms of photon. And the energy of photon is h nu and hc upon lambda. Now further in this model, Niels Bohr studied about the radius, velocity, speed of electron, and so also about the energy of electron. So this is the formula by which Niels Bohr calculated the radius of electron in nth shell. Students, this formula was derived by the postulate of Niels Bohr. In this formula, it is given that radius is 0.529 into n square upon z angstrom. But if you will use the value in picometer, it will be 5.29 into n square upon z. So here is the formula for angstrom. In this formula, we use the value of z is 1 because here we are doing this calculation for hydrogen. If you will use or you will apply this formula to any other species apart from the hydrogen, then you have to put the value of z, which is not 1 in that case. So by using this formula, you can calculate radius of any nth shell for single electron species. Students, why I am saying single electron species? Because let me tell you that Bohr's model is applicable only for single electron species in which only one electron is there. Further in this theory, Niels Bohr also calculated velocity of electron or the speed of electron. So what about the velocity of electron? According to the Niels Bohr, velocity of electron is 2.188 into 10 to the power 6 into z upon n meter per second. Students, by using this formula and by putting the value of z, which is atomic number, and n, which is number of shell, you can find out speed of electron in any nth shell. Just put the value of atomic number and number of shell and you will have the value of speed of electron. So say for example, if we want to calculate the speed of electron, first shell of hydrogen atom. So for the hydrogen atom, value of z will be 1 and value of n will also be 1. So speed of electron will be 2.188 into 10 to the power 6 meter per second by putting the value z and n 1 and 1. Also further in this model, Niels Bohr calculated energy of electron. This is the formulation of energy of electron, which is minus 2.18 into 10 to the power minus 18 z square by n square, and the unit is joule per atom. If you further want to convert this energy into per mole, you have to multiply it by the Avogadro's constant. So by using this formula, you can calculate the energy of electron for any species which is single electron containing, means hydrogen like species, like say for example helium plus, lithium plus 2 or beryllium plus 3, because Bohr's model is applicable only for single electron species. So students, now we studied that this is how, by using this formula, we can calculate the energy of electron in any nth shell, or the radius of shell, or also the speed of electron. These calculations are done by Niels Bohr. Further in this unit, in this chapter, structure of atom, in the next lectures we will tell you about the quantum numbers and the modern model of atom. So this was all about this lecture, students. I hope you liked this lecture. We shall continue this lecture in the next class. Keep coming and keep studying. Thank you for watching.